Hi again, guys. So our second part is the word problem because we always have a word problem so that we know how to use these and what these are actually used for. So our word problem says a motorboat is traveling at a constant velocity at 5 meters per second when it starts to decelerate to arrive at the dock. Its acceleration is at -1/4 t meters per second squared. So we want to find out what is the velocity function and how we're going to find it in order to find our position function. So it says our first question is, how do you find velocity given acceleration? So remember, velocity is like your first derivative and acceleration is like your second derivative. So in the previous example, in order to find the first derivative, we had to take the integral of the second derivative. So we're going to take the integral of acceleration to find our velocity. And we are given that our acceleration is -1/4 t. So to set up our problem, we're going to have our v of t, which is velocity, is equal to the integral of -1/4 t. And instead of dx, we're going to use the variable t for time. So it's going to be with respect to dt. Yeah. So next we're going to take the integral of that and we're going to solve for our initial condition for v of t. So we're not really given our v of t in there as a value, but we could see it from our word problem. So our initial condition for velocity is saying that it stayed at 5 meters per second. So that's what our initial velocity is going to be. So let's go ahead and solve for our velocity equation taking the integral. So we're going to add 1 to the exponents, divide it by the exponent, and we have plus c. So that just simplifies to -1/8t squared plus c. Oh. Next, we're going to solve for what that constant is. So we're going to solve for c by using our initial velocity. So we have v of 0 equal to -1/8 times 0 squared plus c, and we want that to equal 5. And solving just for our c part, we get that c equals 5. So our velocity equation is going to be -1/8t squared plus 5. Oh, easy. Our next part says, now at what time does the velocity reach 0? So what do you think we would have to do with that equation in order to know when it reaches 0? So because we want our velocity to be 0, we're just going to set v of t equals 0 and solve for time. Easy. So we're going to have -1/8t squared plus 5. We're going to set that to 0. I'm going to solve for our time. So we have -1/8t squared equals -5. Multiply both sides by -8. And take the square root. Okay. So on our calculator, see, the square root of 40 is 6.32. And we know that time can't be negative, so that means that we're going to take the positive. So we're going to write our answer as a complete sentence, since it says, what do you do, or at what time does the velocity reach 0? So we're going to say velocity reaches 0 in 6.32, and our time is labeled as, this is meters per second, so it's in seconds. So the velocity reaches 0 in 6.32 seconds. So that means it reaches the dock in 6.32 seconds, because that's when it slows down. So next we're going to find out what is the general position function of the motorboat so that we could plug in any time value to see how far away that motorboat is away from the dock. So to find position given velocity, that means we need to take the integral of our velocity. Because our position is like our f of x and our velocity is our f prime. So we're going to say position, we'll just say p for position at a certain time is equal to the integral of our velocity equation. So our velocity equation was negative 1 over 8t squared plus 5, and again with respect to t. So because this is a step-by-step process, if you get your velocity wrong, then that means you can get your position wrong. So you want to just make sure that you double check all of your work. So you're going to take the integral, add 1 to the exponent, divide it by that exponent, and the integral of 5 is just 5t. We have your plus c. So that now becomes negative 1 over 24t cubed plus 5t plus c. So here's our general position equation. So next we need to solve for our c. So that means that we need to find out what our initial position is. So our initial position is going to be at 0 because it needs a starting point. So that's what we're going to be using. So we have now p of 0, plugging in 0 for our t, and we want that to be 0. So real easy, c just equals 0. So our position equation is then just negative 1 over 24t cubed plus 5t. And we are done.